In this presentations, we are going to discuss about principal source of optimization in the code optimization. So, where the transformations of a program is called local if it can be performed by looking only at the statement in the basic block. Otherwise, it called a global. So, if the transformation is performed within the block, it is in local. So outside of that block to block, that is in global. So many transformations can be performed at both the local and the global level. So that local transformations are usually performed first. Actually local transformations best perform first, then the global. So here in this principal source of optimizations is performed the transformations in two format or formation: function preserving formation and structure preserving formation. So in this function preserving transformations, that can be local. The structures preserving transformations is identify the global transformations. So in this functions preserving transformations, we have this four kind of optimization techniques: common sub-expression eliminations, copy propagation, dead code elimination, and constant folding. So first, the common sub-expression elimination. So what are the expressions are commonly used? That is a sub-expression. So for the one lengthy expressions, so that sub-expressions cannot be repeatedly calculated, so that can be reduced. So the usage of the memory to be reduced. Then example, if we have the T1 is equal to 4 star I, at the same time T4 is also 4 star I. If the value of I does not be changed in this 2-3 address code, means we can use common sub-expression elimination technique. So instead of T4 we can use T1 when the I value not change through this line of execution. And copy propagations. So here if we used any variable like that, x is equal to pi, so what's the value of pi? That is copy into x. And when we write the formula for the area calculation, a is equal to x star r star r. So here we can directly use pi in this formula of area calculations, no need of the x variable. So that is in copy propagation. When copy statements are used to hold the value temporarily, but that is a waste of memory, so that can be removed in this copy propagation. And dead code eliminations, the code cannot be reached until the process completions, that is a dead code, so that to be eliminated, that's in best optimization. So example, I is equal to 0, if I is equal to 1, execute the block of the code between the open brace and close brace. So here before the if statements we define I equal to 0, so whatever the I must be 0, it cannot be changed. I is equal to 1, so no need of this block of executions. So this I statement isn't dead code, we have to eliminate. Then constant folding. So in this constant folding we used a is equal to 3.145 can be replaced by a is equal 1.570, thereby eliminating a division operation. So here a is equal to 3.14 divided by 2. So divided by 2 is a simple division, so we can directly write a is equal to 1.5. If you want to write a is equal to 50, okay, that means we have to write a is equal to 50 instead of a is equal to 100 divided by 2. So that is a simple division. So in this loop optimizations, the unwanted codes are removed, so that here the code movement and motions to be efficient. So here the importance modifications that decrease the amount of code in a loop is code motion. The transformation takes the expressions that yield the same results independent of the number of times the loop is executed. So in this reductions in the strength, so already we discussed the strength means instead of power we can use the multiplications. So x square, so x cap 2, so for that we can write x star 2. If we want to multiply x star 2, for that we can write x plus x. So instead of multiplications we can write arithmetic operator. Thank you.